Hello, so today we're going to be talking about scalar matrix multiplication and matrix multiplication. So first of all, let's make sure we're all on the same page as to what a scalar is. It seems like this big scary word, but literally all it is a number. It's just a fancy way of saying a number or a constant. No need to be afraid. So if we want to take a scalar multiple of a matrix or multiply a matrix by a scalar, let's say like our scalar is 3, we want to take 3 times c. All we do is we take 3 times the matrix. So we have c is 1, 3, 1, 4, negative 7, 3. See, right here. And then we're just going to multiply everything within the brackets by 3. Kind of is like the distributive property. Okay. Now we're just going to take this 3 and multiply every single thing in here by it. So 3 times 1, and then we're going to end up with this matrix. 3 times 1, 3 times 3, 3 times 1, 3 times 4, 3 times negative 7, and 3 times 3 again. So this is what 3 times the matrix c is equal to. So you can just see that this is a scalar multiple of c, our scalar specifically being 3. So scalar matrix multiplication, easy peasy. So let's look at something that's a little bit more fun, a little bit more challenging, matrix multiplication. So now we're going to be looking at matrix multiplication, or multiplying two matrices together. So I'm going to give you a little bit of a teaser and tell you that we can multiply a and c, but we cannot multiply a and b. So when we multiply a and c, we're actually just taking the dot product of each row of a and each column of c. So that's a lot of mathematical mumbo jumbo. So let's see how that works. So you might have talked about the dot product in Calc 3 if you've taken Calc 3. If not, that's totally okay. Basically what the dot product means is we're just taking element-wise, corresponding element, so in the same position if it's the first, second, third in the vector, taking the product of all those and adding all those products together. So we can see this by, if we're taking a and c, we're going to be taking the dot product of the first row and the first vector of c. So what we're going to do here is we're just going to take 1, multiply it by the first entry in C, in the first column here. We're going to add it to the first or the second entry in the first row, and then the second entry in the first column, and then add the first or the third entry of the first row times the third entry of the first column. So you'll notice that we just took our first row times our first column and we put it in our first row, first column of our final matrix. Okay, so now we're going to do the similar thing with our first row, second column. So it's going to go our first row, second column here. So once again, we're going to take 1, which is our first entry in our first row. We're going to multiply it by the first entry of our second column here in C, and then add it to the product of the second entry in the first row times the second entry in the second column, and then add it to the product of the third entry times the third entry. Just like that, and then we can go ahead do a similar thing. So we'll see here again, we have our second row, first column. So we're going to go in our second row, first column here, 5 and 1. Add it to our second entries, multiply together, and then add it to our third entries, multiply together. Okay, and then for our last place to fill in here, it's our second row times second column, second row, second column. So we have 5 times 4 added to 2 times negative 7 added to negative 2 times 3. Okay, now all we have to do is simplify this to find our final matrix. So we have 1 minus 3 plus 3, that's just going to give us a 1. 4 plus 7 is 11, plus 9 is 20. And then we're going to have 5 plus 6 plus, I messed up somewhere. Oh, this is supposed to be a negative 2. See, it's always the simple little copying errors that you make in these. Always be super careful when you're doing these. So we have 5 times 1, which is 5, plus 2 times 3, 6, plus negative 2 times 1, which is negative 2. So we have 5 plus 6 minus 2, so we're going to have a 9 right there. And then you're going to take our last entry here. 5 times 4 is 20, minus 14 minus 6 is going to give us a 0. So this is our final matrix here. So now if we go back and think, okay, so we could do A and C, but we couldn't do A, B. So what are the dimensions on these? So A is a 2 by 3 matrix, and C is a 3 by 2 matrix. So you'll notice here that these two are the same. Because we're taking each row by each column, we need to have the same number of elements in each row of A as there are of elements in the columns of C. So the number of columns of A tells us how many entries are in each row, and the number of rows in C tells us how many entries are in each column. So that's why we need to have the same number of columns in A as we do rows in C. And then if you'll notice here, our final matrix was a 2 by 2 matrix. And you'll notice here, wow, look, the outsides are 2 by 2. So this is our final dimensions. So what we need, if we want to multiply two matrices together, let's say an M by N matrix and a N by P matrix, as long as these two are the same, we know we can multiply them together. That's defined, and we will get a matrix of M by P as our final. So that's why A times B wasn't defined, because there's 3 columns in A and only 2 rows in B. So we'll have a 2 by 2 or 2 by 3 times a 2 by 3. These two are not the same, so we cannot multiply A and B. So there we go. So this is matrix multiplication. But I have a special friend of matrix multiplication to introduce to you, and that is the identity. So you've probably heard multiplicative identity before, and scalar multiplication, where we would have like 1, which is the scalar multiplicative identity, times any element, let's say A. We know that that is equal to A. So it's a similar idea here with like I sub n, which is our matrix multiplicative identity. It is a square matrix, so the n denotes how many rows or columns we have in our square matrix, and since it's a square matrix, same number. So if we have our identity times a matrix of dimension n times m, so we see, oh, it's defined, that's just going to give us a matrix of n times m. So for example, if we wanted to multiply E by the identity, we would have I2 in order for it to be defined. So we have a 2 by 2 matrix times a 2 by 2 matrix, and the identity is always square, times E. We're going to have the identity is defined as a matrix with n rows or columns with 1s all down the diagonal and 0s everywhere else. So for a 2 matrix, we're going to have 2 rows, 2 columns, 1s in the diagonal, 0s everywhere else. Multiplying that here by E, which is 4, 1, negative 1, 2. So now we just do our matrix multiplication that we just learned. So 1 times 4 is 4, plus 0 times negative 1, which is just 0, 1 times 1, which is 1, plus 0 times 2, which is just 0, and then 0 times 4, which is 0, plus 1 times negative 1, just negative 1. And then 0 times 1 plus 1 times 2, so 0 plus 2. So then we'll see here this is just 4, 1, negative 1, 2. And then we've got an e back out. So we see here that the identity matrix times e is just going to give us e. So that's why it's called the matrix multiplicative identity. We're going to be getting to explore the identity more and being able to use its awesome powers here for us later on in this course as well. But before that, I just want to remind you also that it doesn't have to be a square matrix you're multiplying it by. It just has to have the same dimensions. So I invite you to try your own little challenge here to see which identity matrix you would need to multiply d by to get d back out. Okay, so now go have fun, make good choices using your matrix multiplication, and we'll see you next time.